What's up, sports fans? Semester 2, Unit 3 study guide. We're multiplying polynomials in an applied way, and then on the back, we're going to solve some equations. Here we go. Johnny's coffee shop has 2 locations. The owner is planning on expanding the size of one of them. He'd like to hire you to calculate the area of each location. Based on the floor plans below, find the area in terms of x of each proposed space if they bought the neighboring business. Okay, we're going to do all of A, then we'll do all of B, and then we'll figure out what's going on down here. So first, A, the existing coffee shop here, the existing Johnny's coffee shop is represented by these two lengths, 6x minus 2 and then 3x squared plus 5x minus 10. To find the area of a rectangle, we have it right here for you. It's length times width. So we're going to multiply these two together, the binomial times the trinomial. I chose to use the box method. That's what's going on right down here. So I lined it up three columns, 2 rows. 3x squared plus 5x minus 10 is represented on top, 6x minus 2 down the left-hand side. I multiplied each of these values to fill in the box here. 3x squared times 6x becomes 18x to the third. 3 times 6 is 18. X squared times x is x to the third power. 5x times 6x. 5 times 6 is 30. X times x is x squared. Negative 10 times 6x. So negative 10 times 6 is 60. And there's an x with this one here. Negative 2 times each of these items fills out this row here. Then we combine like terms to get our final solution for the area of just Johnny's coffee shop of just portion A. So we have 18x to the third power. Our x squareds, these two terms here get combined. 30 minus 6 is 24. Same is true with our x's. We have a negative 60 and a negative 10. That becomes negative 70. The constant value of 20 cannot combine with any of these, so it came down here by itself. Now, this value here, the area of Johnny's coffee shop, was just written down here. This is the line for example A, and this was our solution just for the area of the coffee shop. The red matches the red. Okay, let's move to the neighboring business. This is where they would expand to if they chose to expand this location. Same sort of thing here. We have a binomial times a binomial, though. This one here, I chose to do the double distribution method just because it's different, not because it's any better. I did box once, I did double distribution here. 5x times 4x becomes 20x squared. 5x times 3 becomes 15x. Negative 1 times 4x is negative 4x, and negative 1 times 3 is negative 3. Combining these two like terms in the middle, they have an x to the first power, or just x by itself. That becomes 11x. 15 minus 4 is 11. Notice how the x squared term and the negative 3 did not combine, and they just came on down. Just like before, I carried that down here to this line here, the 20x squared plus 11x minus 3. The light blue is light blue. Now the last piece here is the waiting room. This one's the kind of the low-hanging fruit. 10 times 12 is 120, and that's where this number here comes from. Now to wrap up portion A, it says, what is the total size, the total square footage after the expansion? So this polynomial here is the result of me adding 120 plus the red stuff plus the blue stuff. So if I look at all of these, I'm really just combining like terms of everything on the top row. This is the only term with an x to the third power, and because we're writing this in standard form with the biggest exponent first, this term here went in front. This 18x to the third is this 18x to the third power. Now we're looking for all the terms with x squared, x to the second power. There's none here in green. Well, we already used that. Here's the x to the second power. We have 24 of them in red, but let's keep looking for more. Okay, there's 20 more here in blue. 24 plus 20 is 44. That's where this 44 comes from. Now our x terms, none in green. We have negative 70 of them in red, minus 70 plus 11 here in blue. Negative 70 plus 11 is negative 59. That's where this came from. Now our constant values. All three pieces here have a constant value. 120 plus 20 minus 3. 120 plus 20 is 140. 140 minus 3 is 137. That's where this total square footage comes from in terms of x. We're going to put that on hold. We'll use it in a little bit after we complete part B. Part B. The neighboring business, or no, let's start with Johnny's Coffee Shop. We'll go in the same order. I'm going to go red, blue, and then green. So here, Johnny's Coffee Shop is a binomial times a binomial. So I chose the box method for red again, just to match what I did earlier. Box for red, I did double distribution for blue. You get to choose your methods. I'm doing both so you can see both. So this box is a 2 by 2 because this is a binomial times a binomial. That is different than the trinomial times the binomial of version A, or question A. 6x times 7x is 42x squared. 6 times 7 is 42. X times x is x squared. 6x times negative 1 is negative 6x. 7x times 2 is 14x. 2 times negative 1 is negative 2. Combining like terms, the x is here. 14 minus 6 is 8. This came down here, this trinomial. The size of Johnny's coffee shop in terms of x, 42x squared plus 8 minus 2. Moving on to the blue stuff, this is the size of the neighboring business, the area of this rectangle here. Same sort of thing, we got length times width. We're going to multiply this trinomial times this binomial. Down here, I did the double distribution method. I took 5x, I multiplied it by all 3. I took -3, multiplied it by all 3. I got a polynomial with 6 terms, and then I combined like terms. So 5x times 4x squared. 5 times 4 is 20. X times x squared is x to the third power. 5x times 5x. 5 times 5 is 25. X times x is x squared. 5x times -8. 5 times -8 is -40. This one's got an x, so this one does too. Now we're all done with the 5x. We focus our attention exclusively on the -3 now. -3 times 4x squared is -12x squared. -3 times 5x is -15x, and -3 times -8 is +24. Negative times a negative yields a positive. Combining like terms, we only have one term with an x to the third power, so 20x to the third power comes down. The x squareds, we got a couple of them. They're not next to each other. It's a little sneaky. 25 minus 12 is 13, so we got 13x squareds. Now our x's, -40 minus 15 is -55, and this 24 is this 24. This whole polynomial here came on down in light blue. Now let's focus on b, this line here. We'll add all these things together here, combine like terms to get this value here. First, start with your biggest exponent. That's an exponent of 3. We only have one term with an exponent of 3, so we have 20x cubed. That's where this comes from. Let's find our x squared terms. There's 42 of them here. There are 13 of them here. 42 plus 13 is 55. That's where this comes from. Now, the x terms, here's 8 of them, and here's a -55. 8 minus 55 is -47. That's where this comes from. Now our constant value, we have 80 minus 2 plus 24. I know that 80 plus 20 is 100, so 80 plus 24 is 104. 104 minus 2 is 102. Okay, now the very last piece of this puzzle, this is how you earn a 4. What's the difference in size here between a b, we're doing b minus a specifically in terms of x. So we're going to take this value because it's b minus this value because it's the result from problem A, and we told you specifically to do b minus a because b is bigger. So it's just combining like terms. We're going to do subtraction. 20 minus 18 because we're doing b minus a. 20 minus 18 is 2, so we have 2x to the third power. That's where this comes from. Now with our x squareds, 55 minus 44, that's 11, so we have 11x squareds remaining. That's where this comes from. Now this one's a little sneaky, -47 minus -59. Minus a negative turns into a plus. So -47 plus 59. It's a little tricky. You might have to write that one out. It becomes 12x. And then 102 minus 37, or sorry, 137. Well, this is going to end up being negative because 137 is a greater value than 102. The result here is -35. Your test is going to look a whole lot like this. Please feel free to pause, rewind, do what you need to do. I'm moving on to the back for your test 2.2. The front is all 2.1, the back is all 2.2. Here we're solving equations. Some of these are going to be decimals, some of these are going to be no solutions, some of these are going to be whole numbers, some of these you need positive and negative. Stay tuned for all the details. Here we go. 7n squared plus 3 equals 52. The move here is to find the value of n that makes this whole thing true. The way that we simplify is generally to deal with the stuff furthest away from the unknown variable. In this case, it's the +3. To get rid of a +3, we subtract it, turn it to a 0. If we subtract 3 from one side, we do it to both. So 7n squared plus 3 minus 3 is just 7n squared plus 0, or 7n squared. 52 minus 3 is 49. Here we have 7n squared. Nobody cares what 7n squared is. We want 1n squared. So we're going to get rid of this 7 by dividing by 7. 7 divided by 7 is 1, and 1 times n squared is n squared. 49 divided by 7 is 7. To get this n all by itself, we got to get rid of the exponent of a 2. We're going to unsquare this or find the square root. So we square root this side to find n. We square root the other side. This is something we throw into our calculator, not a perfect square. So n is positive or negative 2.65. We rounded to the nearest hundredth. That's 2 digits past the decimal. Number 2, 16x squared plus 4 equals 68. Subtracting 4 from each side, that's our first move. That gives us 16x squared equals 64. Nobody cares what 16x squared is, so we divide by 16. If you see it, divide by it, right? Divide both sides by 16 to learn that x squared equals 4 square root of both sides. 4 is a perfect square, so we learn that x equals both positive and negative 2. Again, these are a positive and negative because we're just playing with numbers here. There's no shapes involved, no lengths, nothing like that. Negative 2 times negative 2 does result in positive 4, just like positive 2 times positive 2 is positive 4. So these plus and minus, these are essential. These are a difference maker. If you don't do those, these questions are incorrect. So please recall that. Okay, number 3. Solving for m this time. Subtract 8 from both sides. 62 minus 8 gives us 54. 8 minus 8 is, of course, 0, leaving us with negative 6m squared. Nobody cares what negative 6m squared is, so we divide both sides by negative 6. That causes the negative 6's to go away, leaving us with m squared on the left-hand side. On the right, we have 54 divided by negative 6. A positive divided by a negative is a negative. And then to find m, we would take the square root of both sides, but wait, there's no such thing as a square root of a negative number. So when you reach a situation like this, you're trying to take the square root of a negative number, you can just jump to the conclusion that there is no solution. There's nothing special about the 9, it's the fact that it's negative that causes this to have no solution. Number 4, 3v squared minus 6 equals negative 54. Again, deal with the stuff furthest away from the unknown. I almost said x. In this case, it's a v, though. It doesn't really matter. Treat it the same. Add 6 to both sides. This is where we learn that 3v squared equals negative 48. I know this is a little sneaky. Negative 54 plus 6. That's a big, or a very small negative number, I should say. And then it's getting a little bigger, a little closer to 0. That's negative 48. Here, this v squared is being multiplied by 3, so let's undo that multiplication. Divide by 3. Divide by 3 to learn that v squared equals negative 16. This is a situation just like number 3. We are trying to take a square root of a negative number, and there is no such thing, so we write no solution. Number 5, 4e squared plus 6 equals 30. The move here, subtract 6 from both sides to learn that 4e squared equals 24. Nobody cares what 4e squared is, so let's divide by 4 to turn it into a 1e squared. Divide one side by 4, do it to the other as well. 24 divided by 4 is 6. Find the square root of each side. Throw this into your calculator. That's not a perfect square, and this is where we learn that e equals, or is approximately equal to, positive or negative 2.45, rounded to the nearest hundredth. Number 6, 4a squared minus 5 equals negative 1. Add 5 to both sides to learn that 4a squared equals 4. Divide both sides by 4 because nobody cares what 4a squared equals. So let's get rid of that 4 to learn that a squared equals 1. Square root both sides, and of course 1 times 1 equals 1, but it's also true that negative 1 times negative 1 equals 1. The solution here is when a equals plus or minus 1. Down here we're working with some triangles all mixed up inside of rectangles. We're going to use our guy Pythagoras' theorem here. So the triangle that we have that we're looking at here is the one that's kind of the top half, the upside down. We have the long leg, we got the short leg, we got the hypotenuse. Pythagoras' theorem says a squared plus b squared equals c squared. The a here is 4x, the b here is 21, and the c here is 29. So let's square everything. The tricky part here is that you need to remember to square the entirety of this term, the 4 and the x, not just the x. 4 times 4 is 16, x times x is x squared. 21 squared gives us 441, 29 squared gives us 841. I didn't just know these, I put these in my calculator. I encourage you to do the same. Now we solve it just like all the ones above, but the numbers are a little bit bigger. Subtract 441 from both sides to learn that 16x squared equals 400. Again, nobody cares what 16x squared is. Divide by 16 to learn that x squared equals 25. That's good news. That's a perfect square. Square root both sides to learn that x equals 5. Notice here, this is not plus or minus. This is only a positive result because we're talking about a length. This x can only be 5, not negative 5. 4 times 5 is 20. It makes sense for this side length to be 20. That's a reasonable thing. But if we were to say that solution was negative 5, then we would be claiming that 4 times negative 5, which is negative 20, is a reasonable solution here. You cannot have a side length that's negative. That is meaningless. So only positive solutions when working with shapes and side lengths such as number 7 and number 8. Number 8, the last problem, same sort of thing. We have a right triangle yet again. This time we have leg lengths of 15 and 36, so our A and our B are 15 and 36. Our C value, our hypotenuse, this one here is the longest side of the triangle. It's the side that does not touch the 90-degree angle, so that must be our C value. That's why it's on this side. The same was true earlier with the 29. I didn't say that, but this is our hypotenuse. It's the one that doesn't touch the 90-degree angle, and that's the C value. It's the one that's by itself. It's always the largest value. Back to this one here. 15 squared gives us 225. 36 squared gives us 1296. Again, throw those in your calculator. I don't just know those things. I had to press buttons too. Here, 13x squared, both the 13 and the x are being squared. 13 squared is 169, x squared is x squared. Here we combine like terms. A lot of folks miss this step here. 225 plus 1296, just add them together, you get 1521. Now, nobody cares what 169x squared is, so we divide by 169 to find x squared, or 1x squared. Divide, and we learn that 9 equals x squared. Cool, 9's a good number. That's a perfect square. Square root both sides to find that 3 equals x, and we put our shirt on right side out to learn that x equals 3. Again, just the positive number. We are claiming that x is 3. 3 times 13 is 39. We are claiming that this side here has a side length of 39. There it is. There's your entire study guide. Our next class session, we are taking our test. It looks just like this. Feel free to pause, rewind, fast forward, ask questions. You've got this.